All right, in this video, we're going to talk about 3.2, Objective 3, where we obtain graphs of derivative functions from the graphs of functions. These are all linear functions to start off with, so I'm really just comparing the slopes and seeing which graphs have which slopes and the correspondence here. So let's go ahead and get started. So the graph of function A corresponds to graph derivative. So A is the green line here, and it looks like it has a slope of rise of 2, or rise of 1, run of 2. So slope is 1/2. So 1/2 looks like B. And then B, which is this, B must be this black line here that I don't see a letter for. So looks like it goes up 1, right 1. So that looks like it has a slope of 1. And so that appears to be A. And then the graph of C, C is this red line, and it's going down 1, right 1. So it has a slope of -1. So I see C there. And then graph of function D, it has a slope of +1 as well, just like A did. It's parallel to it. So it's going to have the same derivative. It's also going to be A. So two different functions that differ by a constant. These parallel lines can have the same slope and have the same derivative function. Let's go ahead and look now at number 2. Determine the graph of f prime from the graph of f. So everywhere where there's a sharp point, the derivative is going to be undefined. So it's going to be undefined at x equals -2, 0, and 2. It's going to be a positive slope on the interval of -2 to 0, and from 2 to infinity, it's going to be negative on the interval from -infinity to -2, union 0 to 2. So let's see which meets these characteristics. In fact, it's not just going to be positive and negative, it's going to have specific slopes here. So this slope here is going to be, looks like we go down to right 1. Having trouble seeing that, but I think that it's a slope of -2, I think, for the negative pieces. And I think it's a slope of, let's see, we go to 4, 2, and I think it's a slope of +2 over here. So we'll just check that out. It looks like it is a negative slope, and then it's a positive slope, and then it's a negative slope, and then it's a positive slope. So that looks like C to me for what's going on. We have positive slope, and then we have sharp point undefined, and then we have negative slope. So positive 1, 2, 3, 4. So +4, and then a That looks like -1. So that looks like A. Now we're going to go from negative to 0 to positive. Remember that the derivative of a second degree should be linear. So we want the graph of the function in blue and its derivative in red. So that looks like C to me, should be the linear equation that is the derivative of the blue function, the quadratic. And then, so we're increasing up to infinity. Then we start off at infinity and our slope starts tending towards 0 and then going back towards negative. So we should be increasing, starting at infinity, tending towards 0 and then going towards negative infinity. And then starting at negative infinity and going towards 0, that looks like B to me. And that's it for this video. So we'll come back next time and talk about 3.2, objective 4, where we find points where the function are continuous and differentiable. See you for the next video.